Okay, so in this video, I'm going to talk about rigid body kinematics, and we're just going to start with the most basic form of that, which is translation. So we're going to start off by saying that we have a rigid body. Doesn't really matter what it looks like. He has a point on him called A, and another point called B. That's fairly simple. I'm going to give us an origin. So this is X. This is Y, and I'm going to draw a vector from the origin to A. I'm going to call this one RA. Makes sense. I'm going to draw another one from the origin to point B, and this is RB. And just for fun, we're going to draw another one from A to B, and it's going to be called, my notation is going to be B/A, which describes the vector from point A to point B. So we have this tells us. So we have A and we have B, or we have RA and we have RBA, and then we have RB. So if you're just looking at the geometry of this, we can find that this is just vector addition. So RA plus R from the vector from A to B, RBA, is equal to RB. That makes sense, right? So, we're talking about translation. So obviously there's movement happening. And we want to describe this movement in terms of velocities. So what do? Well, we take the derivative, right? So we know that the derivative of RB is just going to be VB. We know the derivative of RA is going to be VA. But what's this one from from B to A? Well, RA and RB depend on the origin. So if this is moving this way, then RA and RB are going to get larger as it moves away from the origin. But RBA right here, he's not going to change. He's constant. So what happens if you take the derivative of a constant? It's 0. So that tells us that on a rigid body that's translating, your velocity of all points is going to be the same. So our VA is going to be equal to VB. And if we want to take this a step further, we can take another derivative and say that the acceleration at point A is equal to the acceleration at point B. And these are the basic equations. So equation 1, 2, and 3 that describe using rigid body kinematics translation.